Welcome to Education for Next Generation. This is D. Mallikarjun Rao, Senior Physics Teacher. Today we are going to discuss about reflection of light by curved surfaces. To understand this chapter, first we need to recollect the important and basic concepts of reflection of light. Let us go ahead. So, first one is we need to recollect what do you mean by transparent substances and what are opaque substances. Transparent substances are those substances which allows the light rays to pass through them. For example, glass, water. These two materials, glass, water, allows the light rays to pass through them. That means we can see through glass and we can see through water. That is why they are called as transparent substances. And second is opaque substances, quite opposite. The substances which will not allow the light rays to pass through them are called opaque substances. For example, wood, metals, rocks, etc. Wood, metal, rocks, these materials will not allow the light rays to pass through them. That means we cannot see through wood. Suppose this is a wooden object. I cannot see through this wooden object. So, it is an example for opaque material or opaque object. So, basically the substances broad classification is transparent substances and opaque substances. Now, let us come to the definition of reflection of light. Listen, when a ray of light incident on an opaque object, it bounces back into the same medium. This phenomena is known as reflection of light. Here AB is an opaque object. That means AB will not allow the light rays to pass through. Let us assume a ray of light PQ which incident on the opaque object at Q. Here PQ is the incident ray. This light ray PQ cannot pass through the object AB. Why? Because AB is the opaque object. So, it cannot pass through. So, what happens is the light ray bounces back into the same medium in the direction of QR, and here PQ is the incident ray, Q is the point of incidence, and QR is a reflected ray. And let us assume a ray QQ dash which makes 90 degrees with the surface AB. So, the angle between AB and QQ dash is exactly 90. This ray QQ dash is called normal. Now, let us see different parts of this simple diagram. PQ is the incident ray, Q is the point of incidence, QR is the reflected ray, QQ dash is the normal to the surface AB. Now, the angle between the incident ray and normal, PQ is the incident ray, QQ dash is the normal. The angle between incident ray and normal, this particular angle PQQ dash, that angle is called angle of incidence, that is denoted by the symbol I. So, the meaning of angle of incidence is it is the angle between the incident ray and normal, denoted by the symbol I. On the other side, the angle between normal and reflected ray, QQ dash is the normal and QR is the reflected ray. The angle between these two rays is called angle of reflection, and it is denoted by the symbol R. So, finally, the definition of angle of reflection is it is the angle between reflected ray and normal, and this angle is denoted by R. The most important observation is the angle of I is always equal to angle of reflection. The relation between I and R is angle I is equal to angle R. That means if the angle of incidence is 50 degrees, angle of reflection is also 50 degrees. So, whatever may be the angle of incidence, equal will be the angle of reflection. At the same time, the PQ, the incident ray, QR, the reflected ray, QR is a normal, Q dash is a normal, QR reflected ray. All these three rays lies on the same surface, and the incident ray and reflected ray are on either sides of the normal. If one is on the left side, the other one is on the right side. So, the main observations of this diagram is, the first observation is the incident ray, normal, reflected ray. All these three rays lies on the same surface, and the incident ray, reflected ray lies on either sides of the normal. That is the second observation. Third observation is, the angle of incidence is always equal to angle of reflection, and these three observations are called laws of reflection of light. Laws of reflection of light. Our next topic is about the spherical mirrors. First of all, let us know how a spherical mirror is formed and what are the types of spherical mirror, and then the differences between the two mirrors. First of all, let us see how a spherical mirror is formed. To understand the formation of spherical mirrors, first let us take a spherical ball which is made up of a transparent glass. A ball which is spherical in shape, and this ball is made up of a transparent glass. Now, as shown in this figure, slice a small portion of the sphere. Slice out a small portion of the sphere, and this is like this. So, the shape will be like this, like a dish. Okay. Now, it has two surfaces. One is the interior and second is the exterior. And in this diagram, this is the interior surface of the dish and this is the exterior surface. So, whenever you sliced out a spherical surface, you will get a small dish like surface shape, and it has two surfaces. One is the interior and second is the exterior. Now, let us take this first condition. Now, interior surface you polished, just you polish the interior surface thoroughly with the help of the polish powders. That means the interior polished surface acts as a reflecting surface which reflects the light rays when incident on it. The second one is the exterior surface. You apply paint on the exterior surface. That means the exterior surface is painted black, preferably black color. Whenever the exterior surface is painted black, it acts as a non-reflecting surface. That means whenever any light intensity incident on that exterior surface which is painted, the light rays won't reflect back. Okay. So, interior surface is polished and the exterior surface is painted. Interior surface acts as reflecting surface, whereas the exterior surface behaves as non-reflecting surface. And such a type of mirror is called concave mirror. And simple diagram of the concave mirror is like this. Here the shaded region indicates exterior surface and that is non-reflecting, whereas the interior surface is without any shading, that indicates it is the reflecting surface. So, this is a simple way to represent a concave mirror while we are drawing the ray diagrams. On the other hand, see this same dish shape, now reverse. Previously interior is polished, now interior is painted black. Previously exterior is painted, now exterior is polished, and this mirror is called convex mirror. And this is the simple way to represent a convex mirror. See, the interior surface is shaded, that means the interior surface is painted. Exterior surface is not shaded, that means the exterior surface is polished and it behaves as a reflecting surface, and this is the simple way to represent a convex mirror while we are drawing the ray diagrams. So, finally, we have two types of spherical mirrors. One is the convex and the other one is the concave. Convex mirror, exterior is polished, interior is painted. On the other hand, concave mirror is exterior is painted and interior is polished. So, these are the two different types of mirrors that what we are going to discuss in the next class. To understand the functioning of spherical mirrors and how the image will form when object is placed in front of a spherical mirror, we need to understand some important points or important information related to the spherical mirrors that we are going to discuss now. So, the topic is important points of spherical mirrors. There are 6 important points related to a spherical mirror. It may be convex, may be concave. Related to any spherical mirror, there are 6 important items or 6 important points are there. The first one is pole of the mirror. Let us see what do you mean by pole of a spherical mirror. So, this is the concave mirror and this is the convex mirror, and you see this point, the geometric midpoint. The geometric midpoint of a spherical mirror is called as its pole. The geometric midpoint of a spherical mirror is called pole of the mirror, and pole of the mirror is denoted by the symbol P. It may be concave mirror or it may be convex mirror. Pole means the geometric midpoint, and in this diagram P denotes the pole of the concave mirror as well as convex mirror, and this is the first point related to the spherical mirrors. The second important point related to the spherical mirrors is center of curvature denoted by the symbol C. Now, let us see what do you mean by center of curvature of a spherical mirror. It may be convex, it may be concave mirror. Both the spherical mirrors are taken from a big sphere. Suppose here this hole is a big sphere and this part is a concave mirror, and this sphere has its own center. Now, the center of the sphere in which concave mirror is a small portion, that center of the sphere is called center of curvature of our concave mirror. Similarly, this is the convex mirror and this is the whole sphere. Sphere has its own center. The center of the sphere in which the convex mirror is a small portion is called center of curvature of the convex mirror, and you see this definition. The center of the sphere in which the spherical mirror is a part is called center of curvature of the particular spherical mirror, and the same definition is applicable for convex as well as for concave mirrors. Mirrors may be the different, but the center of curvature meaning is the same. The center of the sphere in which the concave or convex mirrors are a small part is called center of curvature of the mirror, and this about the center of curvature, which is the second important point for us. So, first important point is pole of the mirror, and second important point is center of curvature of the mirror. The third important point